Hi, this is Jim Berthold from OLI Systems. This video is about some new features in version 12. We're not going to go through all the features, but we will tell you that we have updated the reactor block located here to include a phase splitter, which was not available in previous versions. We also have introduced a calculator block. This allows us to do some mathematical operations on the flow sheet that are not involved with normal OLI parameters. There's actually two versions of this. This version has a global variable prediction and a local variable prediction. So this part 1 video will be just on the global variables. So we're going to go ahead and create a very simple stream. We're going to start with the chemistry. I always start with chemistry because that's the way I think. And we're going to put in some chemistry that is very typical for OLI's training, and you should be expected to know how to do this on your own. And that's a very simple chemistry. And we're going to just start off with a separator. Okay. We're going to give it a feed stream, event stream, and a liquid stream. We'll just rename them a little bit just so they're easier to see. Again, we're not doing anything earth-shattering here. We're just going to give it some moles, but we're going to change the total flow to volume, and we're going to change the volume to cubic meters per hour. These are actual cubic meters per hour, and we're going to put in 100 cubic meters per hour, but the composition will be in moles. Okay. And we're just going to go ahead and run the calculation. This will help us get some variables that we need. The simulation is done. One of the things that we can look at, and I did notice that I misspelled the word outlet. Spelling does count in this particular type of unit operation. So we're going to start off with some global variables. The purpose of this example is to calculate the resonance time of fluid flowing through this tank. Now, you can calculate the resonance volume by knowing the volume of the tank, which we're going to input, and either knowing the feed or the outlet flow rates. We're going to pick the outlet flow rates here, and I'm just going to add a call out here just to give us an idea of what we have here. We're going to edit, and we're going to talk about phase flows and total volume. Okay. That is in liters per hour, so let's change the units here. Volume to cubic meters per hour. Okay, so it's 32. I must have vented off some material. I did here. Okay, so I know that the tank will be approximately 30 cubic meters. So we're going to go ahead and create a tank of 30 cubic meters and see what the resonance time is. To do that, we're going to start off with a optional property. So we're going to go into optional parameters here. And down here we have this new value, section called Add New Property. Okay. So first thing we have to do is we have to give the property that we want to calculate a name. And I'm just going to call it residence time. Be careful about the spelling that you need to do here. The first thing I want to do is I want to use a property. And this property will be outlet flow. And I'm doing my own math error here, outlet flow. And now I'm going to set a property. Okay. What I want is the phases of liquid 1 Okay, properties, volume. Okay, now this will be in liters per hour, so I can change it to cubic meters here. Now, my sub-expression here needs to be something I can calculate, and this will be the tank volume. So this is just going to be a number. Unfortunately, I can't put units here, so I'm going to put in 30, okay, knowing that that's going to be 30 cubic meters. And now resonance time, is the expression. So I want tank volume divided by outlet flow. Now if I did my math right, there's not enough error checking here, so again, spelling counts. So make sure all my spelling is right, and I will go ahead and click OK. Now I'm going to rerun it. And the simulation is complete. Now I can look at this value of resonance time. Okay, this will appear in the actual detailed report occasionally. Down here in user time here, so that's 0.92 hours. That's what the flow rate is in cubic meters per hour, and that's about right. Okay, the flow is just a little bit bigger than the tank could hold. Okay. Another thing I can do is I can then add a call out of, okay, actually it's the wrong call out I want here. I want the call out for my outlet. Edit. We have user defined properties and resonance time. So you can see it's 0.91 hours. So that's really cool. It does need some work. We know that. So we know we're going to have to add some unit handling here. So what I've been doing is I've been adding a text box that says residence time is in hours. And I do seem to have the bad habit of not getting rid of my caps lock when I type. That's just a note, and I can't spell either. Residence. Okay, there we go. Now we got the math right, and the spelling right, grammar's correct. What can I do with this? I can actually add this parameter to a controller. Since it is a global parameter, let's say I want to control the feed flow rate here in such a way that I get exactly a resonance time of 1 hour. What do I do? So I'm actually going to add a call out here. Okay. We'll edit this. We'll put phase flows in total volume. Okay, so we know we started off at 100 cubic meters, gives us this resonance time. So let's add the controller. This is a normal controller, and we'll hook up our controller parameters. We'll take the outlet here, and we'll adjust the flow rate here. All right, that didn't look so, that's not so clean, so let's make that cleaner here. You just drag some arrows around. A little funky, but that's okay. So let's go into the feedback controller. Okay, so the spec type will be flow. So I'm going to spec variable will be global variable. That's the flow rate. The only one I have is resonance time, and I want to make it exactly 1 hour. Okay. I'm going to control this feed stream. The parameter will be total flow, okay, to get to that resonance time. Okay. It's always a good idea to save your cases as you run here. And global calculator video example. And let's go ahead and run it. And there it converged 3.19 seconds on this computer. I've got a residence time of almost 1 hour. There's a little bit of tolerance here, but the volume, which was originally 100, is now reduced. So this is a way we can calculate a global variable, use it in a controller, and then be able to do some useful work. It's a little bit of a made-up example, but gives you the idea of things that we can do. All right, that concludes this part 1 video. We'll show you another video later on. Thank you.